everyone. My name is Thomas Iché. I'm a visual effects artist at Unity Technologies in Paris. And today I will do a quick talk about the visual effects graph we are developing at Unity and all the interactions we have with Houdini. So today's agenda will be a pretty quick overview of the visual effects graph and to display some similarities we share with Houdini. And we will be mainly talking about how to bridge with offline computations and our Houdini tools we developed for the visual effects graph. And finally, at the end, I will talk about the future research we want to do about the Houdini cross-Unity visual effects graph. To start, we have, so the visual effects graph is basically the next generation real-time VFX toolchain for Unity. And it's targeting basically next generation platforms. So it's fully node-based, and it uses a hybrid paradigm with stackable and nodes that are self-contained into assets. So in the difference of current components in Unity, you can package an effect directly into one asset and reuse it in the scenes and customize its parameters and call events to this on this effect. As I said earlier, it's tailored for next generation platforms. So mainly every platform that is with GPU and compute capabilities. The goals and the philosophy are to keep something powerful yet artist-friendly and data-driven. So no code involved. We want a scalability of features. So basically, we compile our effects instead of composing features that are built in. So basically, we take features from a library and we build a self-contained effect. For the effects we can do, we want to cover a really large range of effects, from really simple smoke, fires, to really large amount of particles, millions. And for the behaviors, we also want to cover really simple behaviors, such as velocity-driven particles, to really complex behaviors, such as heavily mass-driven behaviors. And finally, it's an industry trend in real-time VFX. Basically, last year we had a lot of newcomers and new technologies presented at GDC. And basically, everything goes towards programmable effect behaviors. So we made a demo last year. I will let you check it out. All these effects are made with visual effects graph.
Security check in progress.
Good to see you well.
Access granted.
There's a secure shelter over there. Just pull it lock. Bring the guards and get us to the landing site. You have to get us out of here now.
Select landing target.
much time.
Landing target located. Attention. Multiple weapon signatures detected. Incoming. Shield taking damage. Warning. Power down to 32%. Substantial damage to shield. Power down to 17%. Core energy depleted. Shield power down to 9%.
Sorry, Peter. Sorry.
Warning. Shield has been deactivated. Immediate evacuation. Proceed to the tenders now.
So that was one of our first samples we made using the VFX graph. So basically, from simple effects to all really complex behaviors on the holographic table. So I will review a few concepts we have in Visual FX Graph. So first, we have a different level of editing, and basically that we represent as a pyramid. At the bottom of the pyramid, it's the general purpose and the low-tech and accessible for mostly everyone. So it's just asset instance configuration. So basically, you take a Visual FX Graph that has been set up in your library, you put it in the scene, and you can directly start configuring it, putting it into timelines, call events on it, or even create scripts to access the API in order to make it run. At the middle of the pyramid, it's the graph asset authoring. So it's basically the VFX artist realm. So in this view, the VFX artist design a complete standalone effect, and it defines a parameter interface, an event interface, and everything is packaged. So we hide all the complexity, so it can be used really easily by other people in the project. And at the top of the pyramid, we have the feature creation / editing. Basically, it's a way to improve your feature library by adding a new kind of operators or nodes. And basically, it's intended for TDs, most engineers, or really skilled visual effects artists. And it's basically really similar to Houdini with the OTL design. Basically, at the bottom, the OTL usage and OTL design for the graph assets, and how to extend the library using Houdini Object Model, VEX, or even the HDK. The graph flow is hybrid, as I say earlier, and we have first a vertical flow with a succession of states that we call context. And basically, every context will handle one stage of processing. So we have the spawn context that will just trigger an amount of particles to create. We have the initialize that will just trigger the initial state of one particle. The update loop that is basically the solver, such as a DOP context. And at the end, we render it using different one or many outputs. And basically, what's interesting is we decouple the update from the output, so we can simulate once and render multiple times with multiple shapes. And every context can be fed with what we call node blocks. It's basically a building block of one feature at a time. So it could be, it looks like a lot like wrangle operators, but all these are pretty much artist-friendly and can be fed. Instead of using code, we use operators that we can plug into values. And all these operators are evaluated just like in a regular shader graph from left to right. Sorry. All particles hold attributes, just like point attributes, vertex attributes in Houdini. And basically, we store implicitly whatever is needed. So, for instance, if you want to not age or rip your particle, you will not have to. You will have to just let go about the lifetime attribute. So you will save 2 floating point values per particle, and it's a huge memory saver. We have a library of standard attributes, name, position, color, and we can also, of course, come up with custom named attributes. And all the library of setting attributes, rating the values, can have built-in behaviors such as fetching the value from 2 random states, or fetching the value from a curve, and of course from a texture. Since we run at the GPU, we can read really easily from a texture. And one thing interesting is we can bake attributes in texture to read them offline, so we can hide a lot of complexity inside the texture. So texture are GPU friendly, and as we use HLSL to read the textures, we can either sample the texture using texture blending or access the pixel values directly. And of course, it helps us to do some load balancing between GPU memory by storing, for instance, really complex noise into a texture, or computing noise using ALU directly, so it's more computational, and in the other case, it's more eating a lot of memory. So we can bake 3D noises, PointCache, and generate sign distance fields. So what's the interaction we had with Houdini? And basically, we had really easy interaction because we have mostly the same paradigm of attributes and reading them and storing them. So one thing to note is Unity is not Houdini. Basically, Unity has a real focus on real time and game. So we cannot achieve really complex computations as we do in Houdini. Both of Unity and Houdini are really to script and extend. And for instance, in Houdini, we have a lot of languages we can access, the VEX, the Python, and Unity is all C# driven. So everything is really accessible, even for tech artists. And what's cool is you can easily write exporters and importers, even in Unity using a scripted importer. So it's basically a C# class that will import a given file extension. And in Houdini, you can write really easily files using Python. Finally, in Unity, we don't have any geometry or volume processing libraries. So that's why we have to rely on Houdini in order to bake really complex stuff. So we use the power of SOPs and DOPs and VDBs to achieve basically unlimited results. So we developed mainly two small tools in Houdini. These are really simple. It's a PointCache exporter and a volume file exporter. You can find these OTLs in our GitHub repository. So all these are just simple OTLs. You don't have to set up a full in-house workspace. So everything regarding the code and the script is embedded into the OTL because it helps us distribute more easily the SOP nodes. So first we have the PointCache file. And basically the PointCache file is a dedicated file format which shows to, and it's really close to Stanford PLY, but we just got rid of all the triangle data. And also we added a support for vector data, basically by specifying .x, .y, .z in the properties. And it's supporting ASCII, both ASCII and binary. So it's really, really, really easy to read and write, both in Python and C#. So in Houdini, we have the PointCache SOP that is really, really similar to the file SOP. So we have a conditional export import. And in order to select which point attribute we want to export, we just use selection string. So we can export, for instance, in this example, we can just export position, normal, and color. And we can rename this attribute. For instance, instead of storing just P attribute, we can rename and store it as position. So here we translate, for instance, the N attribute for normal into direction. In the future, we want also to write a ROP network in order to use this node not only as a SOP exporter, but also as a render output. And we need a way to create point cache arrays in order to store vertex animation textures. In Unity, it's when we import a point cache file, it's really simple as we use a scripted importer. So it will detect that is a .pcache file, and it will generate what we call a point cache asset. And basically, it's a built-in asset in Unity that will handle the storage of many textures, one texture per attribute, and it will also reference the point count, stored into this point cache. And when we use this point cache asset in the graph, we have this node here that will reference directly the asset and expose as properties first the point count and one slot for every texture. So it can be read using our blocks named set attribute from map. So it's pretty straight away. You won't have to multiply the textures. It's only self-contained into one asset. Also, we can control precision and streamline re-import. So it's you don't have to re-import many textures and really rewire everything. You can just alt-tab between Houdini and Unity, and it's re-importing really efficiently. Next, we have the vector fields. So it's the .vf file, and it's again a specific file format we add for 3D texture storage. And we made this because Unity cannot import 3D texture at the moment. And basically, we needed some way in order to store efficient floating point vector fields. So the vector field file format is basically binary, and it's really close to TGA file format. So it's uncompressed, and it's really easy to read and write. So in order to write an importer and exporter for another software, it's pretty straightforward. And for now, it's really limited and naive. So basically, we only store a texture resolution and all the values, and that's it. So there is no extent or transform to this 3D texture. And in the future, we want to consolidate the format by adding the, for instance, a bounding volume size and some other information such as distance reference to store sign distance fields. So how does it export from Houdini? It's pretty much the same as the point cache exporter. So it's a SOP node that is using an export condition and just reference to the file and the volume name we want to export. So it's pretty straightforward. Right now, we do not support VDBs because we need to know all the values, and VDB optimize by just clearing some voxels. So right now, we just assume that all the values need to be stored inside the volume. So as for the PointCache exporter, we want to write an alternate ROP exporter and consolidate for signed distance field. So how does it import in Unity? It's really simple. So it imports as 3D textures with floating point precision. But we also added a way to compress more the values using unsigned normalized byte. So it's going to be only normalized into the 0, 1 range and centered to the 0.5 gray. And so right now we don't have any compression. We want to exploit the BC6H signed compression in order to save a lot of memory. And as I said earlier, we need volume bounds and also to be able to import more conventional texture as slice. So here we chose to make a custom file format instead of using existing file format right now, because using existing file format saves a lot of dev time and is supported in all DCCs. But most of the time when you import it, depending on the implementation in all DCCs, it might not match the expectations. And also some software provide discrepancies. So it's not ideal. And what we wanted to make are really naive and simple file formats. So to fit exactly the needs and that we can make evolve as we make the visual FX graph evolve. So it's a lot more of work, and we need to write a specification and maintain them. So it's not ideal because we have a lot of work to do. So in the end, we want to support both having general purpose file format and already well known, and to keep our dedicated file format. So finally, some future research and plans, because we still have a lot of features to implement. And basically, we want to explore the Houdini engine cross visual FX graph to reduce the gap between the two, and basically to be able to create and bake mesh, for instance, in Houdini engine, and exploit this directly in Unity to feed the visual FX graph. We need, as I said earlier, we want to consolidate our exporters and basically add vertex animation texture pipeline, as there's already in the game development toolkit for Houdini. We need in the future, in the far future, to have the VDB importer for visual FX graph, but it would not be limited to the VDB. We want to use the VDB library in a more extensive way. And finally, we need to integrate the optical flow workflow for flipbooks directly and bridge the gap between Houdini and Unity. So I thank you for listening, and if you have some question, I'd be glad to answer them. Thanks. Actually, you can already import PointCache file and vector fields in Unity. And if you want to export these, you can access our Visual Effects Toolbox repository. It's in this slide. It's on GitHub. And basically, when you import this, you will access the OTLs, some examples we made, and also there are some other tools for Unity that are not specific to Visual FX Graph. But if you want to access the OTLs, they are located here.
Numbers of particles / vectors that you can't handle right now? What do you think are some logical boundaries?
Right now on PC, we are pretty confident. On high-end PCs, we are pretty confident simulating millions of particles. It's actually, we are not really limited by the simulation right now. It's more the standard drawbacks of real-time rendering, such as overdraw, transparent overdraw. So right now, when we made benchmarks, the simulation was not an issue at the moment. Basically, right now we can simulate a lot of particles within one component. We have a bit drawback of simulating many components with few particles. So we have also solutions in order to feed many components inside one master simulation. For instance, I worked on a FPS sample from Unity, and it's basically a shooter sample. And for the impact system, we just used the event interface to just send event every time there was one impact on a wall. We just sent the event to one master component in the scene. So it will hold a unique simulation instead of having one simulation per impact. So for that, it's a huge performance saver.
How well is integration timeline?
Right now we have a timeline dedicated track with events. So basically, when you create a clip, there's a string for when you enter the clip and a string for the event when you exit the clip. And for every event entering and exiting, you can set up an attribute payload, for instance, having an explosion at a dedicated position in the scene. So right now it's good, but still we can improve that by, for instance, instead of typing values, having a reference to an object in the scene. For instance, if we want to target a dedicated position. And but right now we have a simple integration that works and that you can extend because everything is in C#. So if you have some dedicated needs and you want to improve features and create dedicated features for your game, you can just fork the project and then start hacking with the C# and improve everything. Okay, more questions? Okay, I thank you for listening, and I hope you will follow us. If you want some more information, you can also follow me on Twitter or join. We have a community on Unity community Discord with a VFX channel. So there are a lot of information going on over there. Thank you.